So, okay, let's have a look at how you go about dealing with ionic and net ionic equations. Now, one thing to talk about here. In these, you will see that the ionic compounds you deal with, which is what you're going to see most of the time, are either soluble in water, which means they're able to dissolve in water. That's this aqueous thing right here. Or they are not soluble in water, which means you'll write an S for solid. Occasionally you'll run into something like H2O, for which you better write liquid, common sense sort of a thing, or O2 or something like that, which, or H2, which you should know as a gas. Okay, generally though, when you see, besides, none of those are ionic compounds. Ionic compounds, if they can dissolve in water, you're going to put AQ. If they cannot dissolve in water, you're going to put S. And in order to figure that out, you need your solubility table. So for those of you watching this video, you need to pull that solubility table out so that you can follow along with that table as I go through how to use the solubility table to complete this and then create a full ionic equation and a net ionic equation. Because your ionic equations will look very different if this is solid versus if this is aqueous, which means you'll put solid if this cannot dissolve in water, you'll put aqueous if it can. So that's the first thing you got to do, is figure out, can these things dissolve in water? So using that solubility table, and you also look at your solubility tables to do this. I got to look up this barium chromate here. So I find chromate. It's under the insoluble, which means will not dissolve in water unless it's one of the exceptions. And barium chromate is not one of the exceptions. Well, barium is not one of the exceptions for chromate, which means chromate's going to follow the general rule of insoluble, i.e. not dissolving in water, so I'm going to say that it is going to be solid in this equation. And then the sodium nitrate over here, got to look that up on the table as well. So here's nitrate in the ions that form soluble compounds column, which means nitrates dissolve in water, and there's no exceptions, which means all nitrates dissolve in water, including this one. That's why I'm writing AQ here. This physical state of solid or aqueous, this determines how I write this out. Because next thing I'm going to do is the full ionic equation. I suppose I should do this one first, whether or not the reaction occurs. Because of the fact that one of the things in the reaction is not aqueous, because of this I say yes, the reaction happens. I'll write it out that way, RXN, my favorite abbreviation for reaction. Okay, so anyway, having done that, having done A, using solubility tables to predict the physical states, and having done B, state whether or not each reaction would occur, yes, because one of the things is not aqueous. I can now do C, full ionic equation. Full ionic equation will go here. Let's see. So if it's ionic and it's aqueous, that means it will split into ions. That means barium nitrate becomes one barium and two nitrates, because this right here means that there's two nitrates in there. So I'm going to put barium, and barium has a 2+. I find that out by looking at the periodic table. And I'm going to put aqueous, because it's dissolved in water, right? Aqueous. And then I'm going to put in the two nitrates with the proper charge and aqueous again. And then the next one, also being aqueous, has two sodiums with AQ and one chromate with the proper charge of 2-. Okay, so that if it's aqueous, break it into ions. If it is not aqueous, do not break it into ions. That means solid, liquid, or gas, leave it as it is here. So BaCrO4. I'll just put solid right there. There's no charge because it's a compound and it cannot dissolve in water. So just solid it is. And then this is aqueous, so this one I can break into ions, this sodium nitrate right here. 2 sodiums and 2 nitrates. So 2 sodiums with a plus charge and an AQ, and 2 nitrates with a minus charge and in parentheses AQ. Let's see. That is the full ionic equation. Yes, it can be a bit of a pain in the butt, but that's how it's done. Net ionic equation. there's two ways to go about the net ionic equation. Way number one, cross out everything that's on both sides, which means I'd cross out these nitrates, I would cross out the sodiums, and then write down here whatever's left for the net ionic equation. Or way number two, write down the thing that isn't aqueous, and then whatever comes together to make it, or if the non-aqueous thing is on this side, then whatever it makes when it comes apart. So I'm going to say, here's your non-aqueous thing, and the barium and the chromate came together, so I'm going to say barium plus chromate makes barium chromate. That's the net ionic equation. Or the other way to go about it, two nitrates on this side, two nitrates on this side, two sodiums on this side, two sodiums on this side. What's that leave? Barium and chromate come together to make barium chromate. Okay, because they're the last ones left after I cross out everything that's on both sides. Or you could say this is the non-aqueous thing, and being that this is the non-aqueous thing, this is what came together to make it. Okay, so that's how you go about ionic and net ionic equations. If you look at number 2, it's going to be a similar process as would number 3. So here's what I'd like you, the viewer, to do. Pause this video and work these out following the same model that was done up here. I am now going to work through the full process, but I would say wait until, pause this video, solve it yourself, and then play out my solving of this and see how it compares to what you did. Okay, so let's go through the process for this too. So using the solubility table, iodine, I find that under the halides, and iodine is soluble, which means it will dissolve and will be marked with AQ unless it's with one of these things. One of the exceptions is lead, and it turns out it's paired with lead here. So lead paired with iodide is not soluble according to this. So lead paired with iodide being not soluble, this led to iodide, I got to put an S next to it. And potassium nitrate, you may remember from earlier, nitrates are soluble and there's no exceptions. So soluble it is, AQ. And due to this, yes, the reaction happens. Alright, so full ionic equation and net ionic equation. So, again, all the aqueous things get split into ions, all the non-aqueous things don't. So, lead's got a charge of 2 because it's paired with 2 nitrates, so here we go. Lead, 2 plus charge, aqueous. Plus 2 nitrates, aqueous. Plus 2 potassiums, aqueous. Plus 2 iodides, aqueous. And all that mixed together is going to make a solid lead to iodide. So I just put it like so. No charge, no nothing. Just stays together because it's not aqueous. And then 2 potassiums, aqueous, because of that. 2 nitrates, aqueous. Alright, let's see, make sure it's all in view or reasonably so. Okay, so once again, I can cross out everything that appears on both sides. You got 2 nitrates, potassium, okay, 2 potassiums. Those are just the spectator ions, they don't participate. I don't have lead on both sides. I've got lead ion and lead to iodide, but this is not the same thing, so I don't cross them out because it's not 2 of the exact same thing. Same thing here. This is different from this, so I don't cross them out. So, what's left behind? This plus this makes this. That's the net ionic equation. Lead, 2 plus, aqueous, plus 2 iodines, each with a minus charge, combine to make lead to iodide, solid, which is to say a precipitate. Okay, so that being done, that leaves the last and final one, and we're going to go about it the exact same way. Alright, so magnesium chloride. According to this, all chlorides are soluble unless it's with silver, lead, or mercury, and that's not what this is. And that's neither silver nor lead nor mercury, so it's soluble. Okay, that's why this is that, and you look at nitrates, you'll see all nitrates are soluble with no exceptions. That's why this is aqueous, that's why this is aqueous. All nitrates, as I said, are soluble without exception according to that table, so we'll go ahead and put aqueous here. And then all chlorides are soluble unless it's with one of these exceptions, the silver, lead, or mercury, which isn't that, so this is also soluble, AQ. Well, what do we have here? We have ourselves a situation where everything is aqueous, 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 and aqueous. It's all aqueous. There is nothing that isn't aqueous. And if you have nothing that's not aqueous, if the whole thing is aqueous, then you can say no reaction because everything is aqueous. Okay, now then I can do this. There's still a full ionic equation. That is true. There's still full ionic equation, so we can go through the full process for that. That's going to include 1 magnesium and 2 chlorines. So magnesium with a 2+ charge, aqueous, plus 2 chlorines with a minus charge and aqueous, plus, this is aqueous, so this breaks up 2 hydrogen ions, aqueous, plus 2 nitrates, and that is going to make as its product 1 magnesium and 2 nitrates and 2 hydrogens and 2 chloride ions. So magnesium, aqueous, plus 2 nitrates, aqueous, plus 2 hydrogens, aqueous, I'm almost out of space here, plus 2 chlorines, aqueous. Ran out of space on the edge of the paper, but I think you get the idea. Okay, there's the 2 chlorines, aqueous with a minus charge. Okay, well, what do you do with this? How do you find the net ionic equation? Trick question. There is no net ionic equation. Here's why. If you go back and, if you look at it, there's nothing that isn't aqueous, so your net ionic equation has to have something that's not AQ. Impossible here. Here's the other thing. If you cross out the stuff that's the same on both sides, magnesium, magnesium, 2 chlorides, 2 chlorides, 2 hydrogens, 2 hydrogens, 2 nitrates, 2 nitrates, you're left with nothing at all. So for your net ionic equation, there is none. Trick question. But, there you go, let's move that up into view. That being said, this is only true for cases where everything is aqueous. And I'm writing that out for emphasis. Okay? You're only going to have no net ionic equation if everything is aqueous throughout the entire equation, which means no reaction because everything is aqueous. Alright? So there's 3 examples. Use your notes and workbooks, or notes, worksheets, and textbook as a source for more practice, not to mention everything out there on the internet. Alrighty, happy studies.